Hey guys, hoping all is well with everybody. In this video we're going to be covering part 2 of the subject topic of volcanoes. Now, recall in our first video we learned a little bit about the structure of a volcano. We talked about the vent being the central focal point of the volcano where the ejecta is released from. We talked about the difference between magma and lava, where magma is embedded in the magma chamber, but is also found in other areas inside the volcano, whereas lava is what is ejected from the volcano in liquid form. We talked a little bit about the different types of lava, and we also talked about the different kinds of volcanoes as well as their statuses. We talked about active volcanoes, dormant volcanoes, and extinct volcanoes. In this video, we're going to be covering a little bit more in detail about some of what is ejected from the volcano. We're going to talk about some geography that is relative to volcanoes, and we're going to also start introducing this idea of earthquakes and the ways that we can measure them, because earthquakes and volcanoes can be very similar in relation to a lot of things. So we're going to start introducing the topic of earthquakes as well. But without further ado, let's go ahead and get started with our first term. Our first term we kind of covered in a general scale last video, where we talked about pyroclastic flow being what kind of goes onto the mountain or volcano and kind of establishes a avalanche-like pace. What we're going to look at in this term is pyroclasts. Pyroclasts are defined as particles or blocks of solid volcanic ejecta, but more specifically we're going to look at it in four different subtypes. These subtypes are volcanic ash, lapilli, blocks, or bombs. Okay, and we'll be looking at those subtypes later. Next thing I want to point out is SAFOD, which is the San Andreas Fault Observatory at depth. Now, to facilitate with this visual, I want to show you guys a map, and I want to show you where San Andreas Fault Observatory is. It is located in California, okay? Now, this is a place where there's a lot of scientific instruments that are used to better understand earthquakes and allow us to make predictions when we study them, okay? Including some materials like a seismograph and other kinds of scales that help us measure the intensity of earthquakes. Now, what I want to do next is introduce to you the idea of a fixed base system versus an isolated base system. Now, this is going to be illustrated with this figure down here. What we're basically looking at was, with a fixed base system, buildings are constructed strictly on bedrock. And I've illustrated kind of what layers of rock are with this figure here. So we have about 4 layers of rock on the ground or on the earth. We have your humus layer, your topsoil layer, your weathered rock fragments, and then your bedrock. And these are what we call divided into horizons. Now, what I want to really hammer home here is with a fixed base system, it is strictly put on bedrock or flat ground. The problem with this is when there is a seismic activity, there's nothing for the building to absorb any energy. So there is a large amount of deformity and damage to these buildings. Nowadays, we have what are called base isolated systems, and these are the most common new construction where buildings rest in isolates that absorb seismic energy. So instead of just having these buildings on a flat bedrock, they're put lower into the ground, but they're also built on isolates, which when a seismic activity occurs, it really kind of absorbs that energy so the building doesn't have to. What I want to really point out with these is the damage and the deformity of these buildings is much less significant, okay, because all of that energy is absorbed by those isolates, okay? So again, we have a fixed base system where the building's just on bedrock, and then we have the isolated base system, okay? Next, we're going to be also introducing the different kinds of scales that we can look at to better understand how we measure things like earthquakes and other related phenomenon. So the first scale that we're going to look at is the modified Mercalli scale. And this scale has 12 degrees of intensity, but it is more measured by what people have felt or observed or even experienced, as opposed to using mathematical numbers what a seismograph itself would read. Okay, so it's more based off observation and experience rather than readings and numbers. The next thing we're going to be introducing is some of the geographical belts that volcanoes can be found on. So I'm going to reintroduce the map here. Okay. Just as a quick recap, we have the San Andreas Fault observation at depth here, observatory at depth. So the first belt that we're going to be looking at is what is known as the Alpine Belt. The Alpine Belt stretches from the northern point of Africa through southeast Europe and Asia and going through to Indonesia. So from northern Africa to Indonesia. The next belt that we're going to be looking at kind of has two different names. The first name is the Circum Pacific Belt, and the second belt that is, I feel, more commonly known is the Ring of Fire. And the Ring of Fire is the major belt of volcanoes that rim the Pacific Ocean. More specifically, the Circum Pacific Belt is the most active earthquake zone that borders the Pacific Ocean. So they do have two definitions, but they do correlate with each other. And basically with the Ring of Fire and the Circum Pacific Belt, we are looking at from off of the coast of New Zealand up through this area here, up through China, up through northern Asia to the coast of Alaska, to Canada, to the United States, to Mexico, to the western border of South America. Okay, and again, it's going to go all the way around, kind of like a ring formation. Okay, the next thing that we're going to look at is the Richter magnitude scale, and this local magnitude scale is what rates earthquakes mathematically by looking at patterns of a seismograph. And basically how seismographs work is they measure vibrations that are made by seismic activity. So it's a device that kind of measures waves and kind of is able to track them continuously. Okay. The last type of scale that we have is the moment magnitude scale, and this is the most reliable measure. And what it does is it takes the measure of a site of a source of vibration or seismic activity, and it converts it into a scale that is similar to the Richter scale. So the reason it's so precise is it takes a reliable measure from an exact source and converts it into a scale like the Richter scale. Now we're going to be looking at more of those pyroclast subtypes. Remember the lapilli, the volcanic ash, the volcanic blocks, and the volcanic bombs. So I'm going to go ahead and take the map down again. Okay. So the first one that we're going to be looking at is lapilli. And lapilli are pyroclastic particles between 2 to 64 millimeters. So 2 to 64 millimeters. Now 64 millimeters is 2.5 inches. So again, this is the lapilli. Okay, so at biggest size it's about 2.5 inches. Now volcanic ash is defined as pyroclastic particles that are less than 2 millimeters. So less than 2 millimeters. This is volcanic ash. Now 2 millimeters is about 0.08 of an inch. So So we have these two ideas of subtypes of pyroclasts are by size. So you have ones that are about 2.5 inches or bigger, or about 2.5 inches, and then you have the ones that are less than 2 millimeters, which is the volcanic ash. The next one we're going to be looking at is volcanic blocks, and that is solid, irregularly shaped lumps of hardened lava after large and boulder-like in their appearance. They often look like large and boulder-like in their appearance. Now, this is very different from volcanic bombs, because the volcanic bombs are going to be, they are formed from lava that is thrown into the air, and basically what happens is it is in a liquid to semi-liquid form, but as it hardens into rock before it hits the ground. So it basically hardens in the air and cools before it even hits the ground. Now, what you kind of want to think about here is that volcanic blocks are solid and irregularly shaped pieces of pyroclastic lava. Volcanic bombs, again, go from liquid to subliquid states to a solid matter before they even hit the ground. So that's kind of the difference. The next terminology that we're going to be looking at is what we call composite volcanoes. And these produce symmetrical, wide-based mountains that consist of alternating layers of lava and cinders. Now remember last video we talked about lava, and we also talked about other materials like ash and rock fragments. So these types of volcanoes, being composite, they alternate layers from lava to cinder to lava to cinder, and that cinder again is that gas and other rocky fragments that form when it is ejected from the volcano. Okay. The next one we're going to be looking at is energy dissipating devices, and we talked a little bit about these with the isolating based systems. It's devices that are added to certain structures to absorb some of the seismic energy. So again, with this figure B, we looked at how isolates, or in now introducing the term energy dissipating devices, really absorb and take in that energy so it doesn't go into the deformity or damage or destruction of buildings. Okay, so last but not least, we have one last term, and it is called igneous intrusion. So igneous intrusion is a process by which magma cuts through other rock layers under the ground. So what's going to happen is when the rock is, or the magma is still in the volcano. Remember, magma is inside of a volcano, and it has this way of cutting through certain layers of rock. So remember, we have certain kinds of crusts and levels in the inside the surface of the earth. So underground, it can go through other levels, kind of like how the levels of humus and topsoil, weathered rock fragments, and bedrock. But this is more topographically speaking on the surface of the earth, whereas magma can go into other layers deeper into the earth's crust and underground. Okay? But this is the end of part 2 of volcanoes. I hope this video helps you guys out. If you guys have any questions about any of the subjects that we talked about, whether it be the subtypes of pyroclasts, the types of scales that we can use to measure volcanoes, anything like that, guys, please don't hesitate to message me. I'd be more than happy to answer any questions you may have. But please enjoy the rest of your day, and again, please be safe, guys, and take good care of yourselves. Thank you so much for watching. Bye.